Sometimes we're given an equation that draws a relationship between variables, and we'd like to know if it's possible to express one variable in terms as a function of the other variables. So we're going to do that here. We were given that 2n plus 6p is 12, and we'd like to know if it's possible to express p as a function of n. So p as a function of n means we'd like to write p as some f of n. So here this is going to be an expression with n only. Okay? So if we do this, that just means we can solve, okay, the equation for p. That's it. So that sentence here is equivalent to saying, can I solve for p, the equation? So let's see. Well, solving for p means, well, okay, I'm going to send a, so this is my solution here. I send the 2n on the other side, and I divide by 6. And bingo, yes, I can actually write down p in terms of n only. Okay, so f of n here, the function would be 2 minus 1/3 of n. Okay, or we could actually call that function p of n. Okay, p of n is 2 minus 1/3 of n. Okay, so p in terms as a function of n is what we call a linear function, because if we graph that function, we're graphing essentially y equals 2 minus 1/3 of n. So if we put n there and y there, we realize this is the equation of a line with a slope of minus 1/3 and a y-intercept of 2, so something like that. Okay, so that would be the graph of p equals, or just the function p. Okay, and I could obviously do the same for n, so I can also, in this case, write n as a function of p, so that's also possible. Now let's look at another relation, a famous relation between x and y, which comes from the equation of a circle. So what's the equation of radius r? And it's going to be the circle centered at the origin. So what do I mean by this? So this is going to be the center of my circle. Okay, r is going to be my radius, and I'm going to draw that circle. Okay, this is my circle, and to get the equation of the circle, I need to be able to determine if I've got a point xy on that circle, what is the relationship between x and y? And this is very easy to answer. If we draw a rectangle like this, a right angled rectangle, the legs of the rectangle are x and y, right? Because x and y are the coordinates of this point right there. So we go x units along the x-axis, y units along the y-axis. And the hypotenuse is actually r. But we know that on a triangle, the hypotenuse squared is equal to the sum of the squares of the lengths of the legs. So in other words, x squared plus y squared is equal to r squared. And this is the equation of a circle. Okay. Now the question is, now that we have a relationship between x and y, okay, so let me rewrite it here. Okay. Is y a function of x? Now x and y could be anywhere, right, on the circle. R here really stands for something that's fixed. It's the fixed radius of the circle. So that's why it's not involved in the question here. I'm not saying is y a function of x and r, because I assume r is something that's fixed. So the variables are really just x and y. Is y a function of x? So to answer this question, I need to ask myself, can I solve this equation for y? So if I try to, I'm going to send the x squared on the other side. And it seems I'm capable of solving for y by taking the square root on both sides. But remember that if you take the square root of if you take the square root, you're going to get something that's positive. So a square root of something is always a positive quantity. However, if I tell you y squared is equal to 4, there actually are, the answer is not y is 2, because there's also another possible value for y. It could actually be minus 2. In other words, it could be, y could be both the square root of 4 or the opposite of that square root. So in other words, here there are two possible values for y, plus or minus the square root. Okay, or I could actually write it like that. Y is this, or y is this. So in other words, for a given x, there are actually two possible values for y. And that means that, well, let's actually write this down. This seems important. For a given x, given value of x, there are, all I'm going to say in general, there are two values of x where actually there's a single value of y. But in general, there are two values of y. In general, there are two values of y, y being the output. So two outputs for a single input, that doesn't sound like a function. Okay? So for example here, if I tell you x is, let's look at a specific case where r is, I don't know, r is 1, okay? So the equation of the circle is x squared plus y squared equals 1. So y is going to be, in this case, either 1 minus x squared, or y is going to be minus 1 minus x squared, okay? Say x is equal to 1/2, okay? Then y could be the square root of 1 minus 1/2 squared, which is, that's going to be root 3 over 2. Or y could be the opposite of that. So I have two possible values for y. And the reason for that is, graphically, if the radius is 1, if you're at 1/2 here, it's pretty clear you have two possible values for y. There's one value for y here and one right there. Okay, so this would be y1 and y2. The positive square root, so this is where you have, y1 is positive, so this is where you'd have the positive square root, and this is where you'd have the negative square root. So that brings us to something called a vertical line test. When you see the graph of a function, if you can do what I just did, draw a vertical line for a given value of x, and you intersect the graph in two places, well, you have two outputs, and that means you're not dealing with the graph of a function. And as I was mentioning before, there are two values of x in this example where there's a single value for y. Can you see what those values of x are? Where it's 1 and minus 1. So at 1 and minus 1, the value of y is both 0. There aren't any two possible values, and we can see this if we replace x by 0 here or there. If we replace, x by 1 here or there, we get square root of 0 or minus square root of 0, which are both equal to 0 for y. And same goes if you replace x by minus 1. So if the graph is not the graph of a function, it fails what we call the vertical line test. Okay? So I'll show you some other examples here. So imagine I've got a curve that's like that. Okay. Well, If you want to know, is this the graph of a function? Okay, you can, in your head or on paper, you can draw like vertical lines like this. If you see one that intersects the graph in more than one place, that means that for that value of x here, so this value of x here, there are three outputs, three values of y, right? There would be three values for y here. It'd be y1, y2, y3, and that's not possible. So that means y is not a function of x. Okay, so here y is not a function of x. If you've got a curve like that, let me try to do it again, like that. Okay, if I draw vertical lines, I'm intersecting the graph in only one place each time. So this is actually y is a function of x in this case. Okay, because it satisfies the vertical line test.